Hi everyone, Chris Tisdell here again. Thanks for tuning in. In this presentation, we're going to continue our gentle introduction to linear systems and simultaneous equations. Now, in previous videos, we looked at how to solve two equations with two unknowns and the geometry of that. We also did an example with two equations and three unknowns, and that's going to be the idea of today's presentation. And in particular, we're going to discuss the case where the two equations have no solution. So geometrically, you've got two planes and they're parallel, but they don't touch. Okay, so let me share my screen with you. Now, this is the example we're going to look at today. You've got three unknowns, x, y, and z, two equations. You're asked to solve this linear system. Now, we know from a procedural point of view that the idea is to convert the linear system into some sort of simplified form that reveals the nature of solutions. And we can do that using these three steps. We can interchange equations, we can multiply an equation by a non-zero number and add a multiple of one equation to another equation. Now, before we get down to the example, what is happening geometrically? Well, these are equations of planes. And the two planes will either touch each other along a line of intersection, and you've got an infinite number of solutions. You can have parallel planes, but the planes not touching each other, and therefore no solution. Or you can have parallel and identical planes, planes that lie on top of each other, occupy the same set of points. In that case, you have an infinite number of solutions. So let's work our way through this example, and we'll see how we go. So one thing I like to do is to label equations. So here we are solving this problem. Okay, so essentially you can see that the left-hand side in equation 2 is twice the left-hand side in equation 1. Okay, that's not true of the right-hand side, but it is true of the left-hand side. So let's try to simplify by let's, for example, take equation 2 and take away 2 times equation 1. That will give you 2x minus 2x, negative 6y minus 6y, and 6z minus 6z. Now, on the right-hand side, you're going to get 10 minus 2 times 2. That's 4. So we end up with the crazy thing, 0 equals 6. Uh-oh, have we broken mathematics? Well, no, we've come up with some sort of nonsense, but all this means is that our linear system has no solution. So let's write that down. Hence, our linear system, 1, 2, has no solution. All right, now geometrically, what does this mean? We have the case 2 here. Parallel planes that don't touch each other. Okay. So that represents a plane, that represents a plane, but they don't touch each other. Okay, so let's see if we can do a picture. I'm going to use GeoGebra. GeoGebra is awesome because it's free and it's now got 3D graphing capabilities. So let me show you that. All right, so here's one I created earlier. Let's pull it away. Here you've got the XYZ space. Let's put in one of our planes and the other one. And let's move it around a bit. You can see they're kind of close together, but they don't touch. They're parallel planes. All right, so they never touch. So hopefully you can see that all right. So there you go. There you have it. Two parallel lines, two parallel planes that don't touch. No solution. And it was pretty easy to show that. We just ended up with some kind of nonsensical statement. What do you think? If you have any comments, any questions, I'd love to hear them. Put them in the comments section. If not, stay tuned for the next video on linear systems. We'll do another example like this, but in this case, the planes will be identical. Thanks again for watching. Bye.